Okay, so imagine that we've got, like, say, the wheel of a bicycle or something like that. Okay, and let's suppose that that bicycle wheel goes through some angle, rotates through some angle theta, right? When we talk about the tangential relationships here, the tangential relationship here would be between theta, the angle, and the linear distance on the edge, right? So this is a linear distance on the edge. We could also talk about a wheel that's spinning, right? Okay, so if this is, say, a wheel on your car, this would also be how fast your car is going, right? So we could talk about the tangential velocity, right? And then we can also, if your car is speeding up, the wheels have a tangential acceleration, which is, of course, equal to the acceleration of the car, right? So these are things that are happening at the edge of the wheel. Okay, these are linear things, right? Tangential relationships, things that are happening right at the edge. So the distance the wheel rolls through, the speed the wheel is moving, the acceleration of the wheel, the linear acceleration, right? Um, and the relationship is really very simple, and they're all the same. Okay, like for example, if I want to know S, I just know that S is theta r. So let's just hit the right arrow here. Okay, that is not in the data packet, so they're assuming that you understand the basic definition of a radian and angles and all that stuff, right? If you don't know it, memorize that thing, right? Okay, so that guy's not in the data packet. Oddly, the tangential velocity is in the data packet. They've got that in there. Okay, so this is so basically you just take the angular quantity, right? This is angular displacement multiplied by the radius, you get linear displacement. Angular velocity times the radius gives you linear velocity, and you guessed it, angular acceleration times the radius gives you linear velocity. Okay, so these are the angular double, right, of these things, right? And all you do to translate it into what's going on at the edge of the wheel is you just simply multiply them by the r. It's easy peasy. Okay. Obviously, to get the angular quantity, you divide the linear quantity by the radius, and you get the angular one. Okay. And you see these all the time in rotational mechanics, so you have to be good at this. All right.